This video is going to look at refraction. It's going to review, in it we're going to review the activity from yesterday briefly, and in order to get an understanding of what refraction is and why it's an important property of light to understand. In order to understand what refraction is, we first have to look at how light travels. So we know light travels in straight lines, but we have to look at the speed at which it travels. So this picture is showing a representation of the speed of light, or hyperspace. So we know that light travels at about 300,000 kilometers per second in a vacuum or in space, so where there's no air. So this is called the speed of light. Refraction occurs when light travels through a different type of material and light is actually slowed down. So here's an example. So this is my window, the blue thing, and here's my light ray going through. So this is air, and this is glass. The window's made of glass. So what's happening is when the light travels through this piece of glass, it ends up slowing down. Whoops. Ends up slowing down the light. And the result of it is bending of light. So it's bent or refracts. So if we look at the example that we did yesterday with the interactive simulation, I did some data. I drew my data out just for a couple of instances. So in this data shows that the incident ray, or the ray that's going into a different material, is in air, and then it's going into water and glass. And you'll notice that in water, the refracted angle is 40 degrees versus the incident angle being 60 degrees. And then in glass, the incident angle, in air it's still 60 degrees, and in glass the refracted angle is 35 degrees. So basically what's happening is light's traveling from air into a different medium or substance, either water or glass, and it ends up bending the angle at which it goes into that material. So now, what's a scientific definition of refraction? Well, refraction involves changing direction or bending of light. So it's when light changes direction or it bends as it travels from one medium or one substance to another. So why does refraction happen? Well, if we look at an analogy of a car on ice, this will explain it. So think of a car driving on a road and all of a sudden it hits ice. When the car is driving and its front wheels hit the ice, it causes the back end to flip outward. So this is what is shown in this diagram here. This car's back end's flipping outward. The car continues to move forward, but in a straight line, but the direction of the car may change. So here's your straight line. The car is still going. The direction's changing direction. That is essentially why refraction happens. Refraction of light happens. Light hits a material. It continues to travel in a straight line, but whatever medium it hits causes it to change directions. Now if we go back to the example that you did, or the little lab activity that you did, and we look at the different angles of refraction here, there's something called a refractive index. And the refractive index is essentially, it's a measurement of how much the speed of light is changed or reduced. So that determines how much a material, how much light is going to bend depending on the type of material. So for glass, the refractive index is greater than the refractive index of water. So it causes the light to bend more in glass than it does in water. So glass, if we look at different refracted indexes, glass has a refractive index of about 1, whereas a diamond has a refractive index of about 2.42. So light bends more when it passes through a diamond, so that's why it's the light, it makes light look very shiny when you look at a diamond compared to when you look at glass. So now, what are some real-world applications that actually matter, where refraction actually matters? Well, if we talked about some of these yesterday in our discussion. We talked about spearfishing, so locating a fish underwater isn't actually where it is because you're going from air to water, so you have to know where to throw the spear in order to catch the fish properly. Another example is a mirage. So that's when you look in, when you're driving on the road and it looks like there's water on the road, but there really isn't. That's the result of refraction. I also talked about magic tricks. So this guy here is using physics to demonstrate refraction and do a magic trick to show, hey, his head's actually cut off, but it really isn't. And finally, the most practical application that we're going to be looking at later on in this unit is the idea of glasses and using lenses to correct vision. One of nature's examples of refraction is a rainbow. So we're going to discuss what causes a rainbow and why we actually have rainbows. Before we can actually get to that answer, we have to look at a little bit more into the properties of light. So we scientists know that visible light exists in the form of waves. So it's also in the form of waves in a spectrum. So our spectrum, or a rainbow, is red, orange, yellow, green, blue. I'm just going to draw those out. And I'm purposely making those waves, or the wavelengths, shorter as I go up, because each color has a different wavelength. The red has the longest wavelength, and violet has the shortest wavelength. Whoops. So this all together, all of these, the spectrum makes white light. We can't actually see the different colors separately, except when we look at a rainbow, and then we're going to discuss later on why we see the colors we do, and that this will help explain it, as help provide that explanation. So now let's look at how a rainbow is created. So we're going to look at an example of how a rainbow is created through a raindrop. So after it rains, we usually see a pretty rainbow in the sky. Well, this is because the white light, here's my white light, from the sun is hitting that raindrop. And when it hits the raindrop, it's going from air to water. And we know when light goes from one medium to another, it causes it to refract or bend. So that white light's moving into the raindrop, and let's see what happens. So as it goes and does that, because light travels, white light is made up of a spectrum and they have different wavelengths, it causes the different wavelengths of light to break apart and to refract or bend and reflect, so that's reflecting out. So there's my red. If I go to the end of the spectrum and go to my violet, it's causing it to bend at a different angle because they travel at different wavelengths. So if I go orange, and this is not perfect by any means, not measured out, but basically what's happening is when it goes into the water, it causes the light to bend, and because it's bending, it's breaking all of the spectrum colors apart. It's reflecting outwards to create your rainbow. Just about done. Getting kind of messy. There we go. Green. So this can also happen in a prism. So when we looked at the triangular piece of glass, or you notice sometimes when you have sun catchers work like this too, because they cause the light to be caught within. It causes the light to bend and break apart into the different colors and then reflect out into a rainbow. So now hopefully you have a better understanding of what refraction is. So it is a change of direction of light when it goes from one medium to the next. Or bending, right? Light bends. Hopefully you also understand that there are some examples, real-world examples and applications, and the one that we are going to look at are lenses. And finally, that a rainbow is an example of how refraction works. It also is an example that light travels in straight lines as well, and it can be reflected. But refraction was the area that we looked at. So hopefully you have a better understanding now, and we will continue to look further into how refraction helps us with being able to correct our vision.